Welcome to this explainer. So, if you've ever tried setting multiple AI coding agents loose on your repository, you've probably hit some really weird, totally silent errors and pulled your hair out wondering why. Well, today we're diving into exactly why traditional Git workflows completely break down under an AI workforce. But more importantly, we're going to discover how a built-in, but honestly often ignored feature called Git Worktrees elegantly solves this entire problem.
Here's our roadmap for today's explainer. First, we'll cover the parallel agent problem, then what Git Worktrees actually are, the concept of shared objects and private files, deferring conflicts to merges, and finally, orchestrating the agent fleet. Let's jump right in.
Part 1. The parallel agent problem.
Imagine running 4 or 5 AI coding agents simultaneously on a single codebase. You'd think you'd get a massive speed boost, right? Instead, it's basically like putting 5 highly caffeinated developers on a single keyboard. You get failure modes that perfectly mimic distributed systems concurrency problems. The traditional single working directory model simply shatters at millisecond speeds.
It turns out there are 4 major failure modes here. You have concurrent file overwrites causing silent data loss, and context contamination where agents act on a completely stale view of the code. Then there are shared state race conditions and fatal lock contentions. But you know what the scariest takeaway is? Unlike humans who get confused and stop working, AI agents will literally just proceed silently on corrupted data without batting a digital eye.
Oh man, if you've used Git, this error message has absolutely given you nightmares at some point. Git uses file-based locking to protect the repository. So when 2 autonomous agents try to stage code at the exact same millisecond, boom, you get this fatal index.lock error. And if an agent process happens to crash while holding this lock, the entire fleet freezes until a human manually intervenes. It's just a complete bottleneck.
Moving on to part 2. What exactly are Git Worktrees? The real secret to fixing all this chaos lies in the concept of a single canonical object store. Inside your normal .git folder is an objects directory. That's the heavy lifting, your history, your blobs. And it's totally separate from the physical files you actually edit. Because Worktrees rely on this central hub, spinning one up is incredibly fast and disk efficient compared to running a full Git clone every single time.
So what this really boils down to is isolation without duplication. Git Worktrees let a single underlying repo support multiple working trees all at once. You're giving every single AI agent complete file system isolation, its own little sandbox, without duplicating gigabytes of heavy repository history.
Part 3. Shared objects, private files.
This two-pointer architecture under the hood is honestly brilliant. On one side, you have the shared state, the single object store and commit history, keeping disk usage super low. But the real magic is the private state. The private working directory gives every single agent its own staging area, its own index file, and actual physical files, meaning Agent A's staging area is completely isolated from Agent B's, totally eliminating that dreaded lock contention.
Specifically, this works via 2 environment variables. Gitdir points to the agent's private folder, and gitcommondir routes back to the shared history. But notice the exclusivity constraints here. Git literally prevents 2 worktrees from checking out the exact same branch. So an agent's uncommitted edits are totally invisible to the rest of the fleet, letting them operate at full speed, completely unbothered.
Which brings us to part 4, deferring conflicts to merges.
This concept just completely hits the nail on the head. The conflict problem moves to the PR merge stage. Look, worktrees don't magically erase code conflicts, they defer them. And this is a massive paradigm shift. By doing this, we convert silent, disastrous runtime overwrites into standard Git merge conflicts. And hey, as developers, we already have decades of excellent diff tooling to resolve those.
When comparing isolation strategies, Git Worktrees absolutely win on speed. They take seconds to create because you're literally just checking out files. But quick caveat here, Docker is still required if your agents need runtime isolation. Like if 2 agents try to spin up a dev server on port 3000 in 2 different worktrees, they're going to collide. But for just writing and staging code, worktrees are the undisputed champion.
And finally, part 5, orchestrating the agent fleet.
So how do top-tier platforms actually build this into reality? Well, they follow a very structured, agentic software development lifecycle. First, a space is created which initializes a dedicated worktree. Next, a coordinator agent plans and decomposes the tasks. Then, specialized agents execute those tasks concurrently on separate branches inside their own isolated worktrees.
And finally, a verifier checks the results as an automated quality gate before a human ever even looks at it.
This setup gives us a highly effective three-tier architecture. The coordinator is basically your tech lead. The specialists are your individual contributors writing the code, and the verifier acts as your automated QA. And because this relies on a worktree per task model, it's perfect for ephemeral agents. You spin the worktree up, the agent does the job, you merge the PR, and you destroy the worktree. Fast, clean, and completely isolated.
Okay, but if everyone is totally separated in their own sandboxes, how do they stay aligned on the larger goal? The glue holding the entire fleet together is what's called a living spec. It's a shared coordination document that all agents read from and write to. As agents complete tasks in their private worktrees, this spec auto-updates. It's a continuous source of truth, and a human developer can always step in and edit it manually to correct the course if needed.
So by adopting Git Worktrees, we're effectively curing that multi-agent concurrency problem at the file level. We're converting those invisible, cascading failures into highly visible, totally tractable merge conflicts. So, as we wrap up today's explainer, the real question I want to leave you with is this. Are you ready to upgrade your isolation primitives and unleash a parallel AI fleet on your own repository? Thanks so much for joining me on this explainer, and I'll catch you on the next one.